All right, hello everyone. We are going to start our science HBL lesson with chapter 4, separation techniques. I understand that some of you may have already started this lesson, but just bear with me because there are some of your classmates from other classes that have not started on this topic. So therefore, today what we're going to be looking at something quite important. All right, for those of you who have already started this topic, we just take this lesson as a revision, all right? So today we are going to be talking about, first of all, the importance of separating mixtures. We will then move on to talk about the different types of methods used to separate mixtures. Now, if you remember this word mixtures, you would have learned that in the previous chapter, okay, our previous chapter of chemical properties, we said that there are two types of mixtures, right? There are solutions and there are also suspensions, okay? And these two can be considered as mixtures. So today we're going to be talking about how these mixtures can be separated, because mixtures are actually either mixtures of elements or compounds that are not, okay, chemically combined. And that is why it is easy to separate mixtures. Okay, and then after that, we will be talking about how Singapore, okay, actually gets drinking water from non-potable water. Okay, now what's the meaning of non-potable? It means water that cannot, okay, cannot be drunk. And these will be usually untreated water. All right. Okay, so let's now move on. You should already have your notes in front of you. Now, there will be certain parts of the video where I may ask you to pause, and I'll give you some time to actually fill in your blanks. Now, if you find that the video is a little bit too fast, then please pause at any point of time, all right? Okay, so let's move on. Okay. Okay, so can you recall in chapter 3, all right, we learned that we actually learned that elements, all right, matter can be classified as elements, compounds, and mixtures. Okay, we learned that there are two types of mixtures as mentioned just now. And what are they? They are actually solutions and suspensions. Okay, you may want to write this down now. Okay, so Miss Lee has mentioned that basically can be chemically combined, can be classified as elements, compounds, and mixtures. Okay, and there are two types of mixtures, your solutions as well as your suspensions. Okay, so you can see that over here, all right, under elements, remember your periodic table. Okay, if you can recall your periodic table, what is your periodic table? Your periodic table is basically a table of elements that allows you to group them into metals and non-metals. Okay, and then of course you have your compounds. All right, your compounds are when two or more elements are chemically combined together. And then of course you have your mixtures. Now your mixtures, you can have mixtures of elements, you can have mixtures of elements and compounds, or you can have mixtures of compounds. But the difference between mixtures and compounds is the fact that mixtures are not chemically combined. Okay, so under your mixtures, what do you have? Okay, under your mixtures, as mentioned, you have solutions and suspensions. Okay, so you may ask yourselves, why do we want to separate mixtures? What's the purpose of separating mixtures? Okay, now whenever you separate something, it's because you want to get something, right? You want to get the ingredients of it. So mixtures, for example, like your air, your seawater, and your crude oil, they actually sometimes contain useful substances. And when we separate mixtures, it basically allows us to obtain these useful substances, okay? So allow us to obtain these useful substances. You may want to highlight that, okay? So separation allows us to obtain useful substances. All right? Okay, the next thing is that separating mixtures also allows us to ensure that substances, okay, such as your food, all right, your beverages and your drugs are actually pure. Okay, now, so we want to make sure that they are pure. So when we separate mixtures, we want to make sure that we, number one, can get useful substances. Okay, we are also able to check whether these substances, for example, like food or even drinks or even drugs, sometimes the companies will say that, oh, these drinks or these drugs are pure. So how do we know that they are pure? And if we separate them and if there is more than one substance that's coming out from them, most likely the company is probably lying to us because they are not pure substances. Okay, so let's go on to page 2. What is physical separation? All right, now physical separation involves many different types of techniques. Now, if you look at the term physical separation, all right, it means that these are techniques that allow us to separate mixtures. Now, there are a few types, okay? Over here, you can see that you have magnetic attraction, you have filtration, you have paper chromatography, and you have simple distillation. Now, these are some of the methods that we will be talking about that are known as physical separation. Okay, now why are they called physical separation? Because not only do they allow us to separate mixtures, you will also know that chemical reactions are not involved. That means when you separate these mixtures using these methods, there are no chemical reactions involved. There's no breaking of any bonds. All right, can we please write this down? Okay, so why do we say that there are no chemical reactions? Because we say that no chemical bonds are broken. So you may want to write this down in your notes. Okay, so no chemical bonds are broken, and because no chemical bonds are broken, there are no new substances produced. Because remember, mixtures, in your mixtures, right, they are not, okay, chemically combined. Okay, so you have a few types of methods. We'll be looking at magnetic attraction. I'm sure that some of you might be thinking, what does magnetic attraction mean? Obviously, it involves a magnet. That means there must be some substances that could be metallic in nature. Okay, now what is filtration? I'm sure all of you remember from chapter 1 that we said this is a filter funnel, this is a beaker, and this is a conical flask, right? So in filtration, we are probably trying to separate something that is in the solid form in your liquid mixture here. Then this is probably something new, which is quite important. It is known as paper chromatography. Therefore, you know that it will involve some form of paper. We will figure out what this is later. And this is probably the newest to you. This is known as distillation. All right. So now let's continue. Now, what do we say? We say basically the original substances are obtained at the end of the process. Now, what do we talk about what do we mean when we talk about original? Original substances means, okay, either the compounds, all right, the compounds or the constituents, that means the ingredients, okay, for a lack of a better word, the compounds or the ingredients that are used to make the mixture. Okay, so these are what we call the original substances that are obtained at the end of the process. So physical separation, that means something that you can see, all right? It separates mixtures. Chemical reactions are not involved. And at the end of the physical separation, you will actually get the original substances. However, because sometimes some mixtures are a little bit complicated, so you will require 2 or more physical separation techniques to separate a mixture. We will figure out what this means later on. Okay, now if you would like to copy down your notes at any point of time, you are able to pause the video. If not, we will continue. Okay, so let's move on. So point number 5 on page 2, we can say that mixtures can be separated using the following. Can you tell me what you think this P word is? Yes, you are right. Physical separation techniques. Now, what are some of the physical separation techniques that we'll be looking at? Okay, so this is a very important part. So please make sure that you bold this or you take this and you highlight inside your notes, because you will be tested on how to identify these separation techniques. So the first one, you guessed it correctly, it will be magnetic attraction. Okay, you may want to pause the video if you need to fill in your notes. Next thing will be filtration. All right. E will stand for evaporation. Good. Some of you are guessing it correctly. Now, what does S and D stand for? It stands for simple distillation. Last but not least, okay, the fifth separation technique that you will be learning about will be paper chromatography. So you may pause the video now to make sure that you fill in the blanks in your notes on page 2 and check that your spelling is correct. All right, so let's move on. Now, depending, you may ask this question. How do we know what separation technique to choose? How do we know if we are going to use magnetic attraction, or if we're going to use filtration or evaporation or simple distillation or paper chromatography? Basically, it really depends on two factors. Now, these two factors are, number one, the physical properties of the substances present in the mixture. Now, if you talk about your physical properties, so because you know that there are many different substances that can be present inside the mixture, these substances are not chemically bonded. Okay, and depending on the type of physical properties, for example, their melting point, their boiling point, okay, their solubility. So these type of properties may definitely affect the type of technique that you will choose. Next thing, it also really depends on the substances that you want to obtain from the mixture. Okay, so for example, if you want to get a liquid from the mixture, if you still want to get a liquid, you may choose, you will definitely not choose evaporation, because you know that in evaporation, let me draw something very quick for you. So if you know in evaporation, you will probably evaporating dish, right, over your wire gauze, over your tripod stand, right? And then you will probably heat this over a non-luminous flame because it's quite hot. So you might have a mixture here, let's say, of a sugar solution. So when you evaporate, what will happen is that all the water will turn into water vapor and evaporate. Only the sugar or the salt crystals will be left behind. So if, let's say, the substance that you want to obtain from the mixture is basically water, then you will not choose evaporation. But if you want to obtain, let's say, salt or sugar, then you may want to choose evaporation, because evaporation will allow the water to be removed, leaving behind only the salt and the sugar crystals. So remember, the type of separation technique that you choose, either one of these 5 separation techniques, will have to depend on, number one, the physical properties, and number two, what kind of substance that you want to obtain from the mixture. So these two factors are quite important. So please make sure you highlight this in your notes. Okay, these are the ones that will determine the type of method, okay, that you will choose to separate your mixtures. All right, so let's move on. Okay, so we are done with 4.1, right? We talked about the importance of, we basically talk about the importance of separating mixtures. Why do we want to separate mixtures? Okay, so let's do a brief revision first. We're going to write this out in the notes. Can you think about why we want to separate mixtures? What is the importance? Good. If you guess that we want to get useful substances, you are absolutely right. Okay, so these useful substances are basically the original, okay, substances that make up the mixture. The second reason why we want to separate mixtures is we want to identify if the mixture is pure in the first place, if this particular substance is pure. Now, if you separate and then you realize that, actually there's more than one substance that is coming out, then you know the substance is not pure. So there are some government agencies in Singapore, for example, overseas, like there's one that's under FDA. In Singapore, we have your AVA. They help to determine the purity of a substance, and they basically use different types of physical separation techniques to be able to do that. Okay, so now let's move on to 4.2. Now in 4.2, we're going to be discussing the types of separation techniques. You can go back to page 1 and look at what are your objectives A, B, C, and D. Okay, so first of all, we are going to be talking about the first type of separation technique, and that is known as your magnetic attraction. So if you look at this picture over here, okay, you can see there's a question over here, right? Now the question says, how do you separate a mixture of iron fillings from sulfur? Now you can remember this is very similar to your question in your theory workbook, all right, when we ask you how are you going to separate your iron filings from your sulfur powder. Okay, so why do you think the person is actually using a magnet? That's because the magnet will attract the iron, leaving behind the sulfur, because sulfur, you may want to write this down, okay, because sulfur is a non-metal. That means it will not be attracted to magnets. And since it will not be attracted to magnets, it will be left behind, but all your iron filings will be attracted to the magnet. And since all your iron filings will be attracted to the magnet here, you are basically separating iron from sulfur. So this is quite a useful method if you have a metal and a non-metal mixture. Okay? All right, so let's move on now. So we said that magnetic attraction is the separation of magnetic materials from, yes, you guessed it correctly, from non-magnetic materials. Okay, you may want to highlight this. Okay, it is the separation of magnetic materials from non-magnetic materials. So please highlight this in your notes. Take out your highlighter. Okay, and highlight this. It only uses the fact that some materials are attracted to magnets. Now you can remember on page 3, all right, Miss Lee actually told you that that the two factors that really affects what kind of technique that you choose will really be dependent on your physical properties or the kind of substance that you want to get. Now if you go on to this page, you would notice that you will only use magnetic attraction when there are materials that are attracted to magnets, right? So can you please write this down in your note? This part here, when materials are only attracted to magnets, can you tell me which factor is this? Is this a substance that you want to get, or do you think this is a physical property? You're right. Okay, this is a physical property. So the physical property of the substance must be it is attracted to magnets. Okay, so you will not use this material if you have substances that are not attracted to magnets at all. So this is basically one factor that will influence the type of method that you want to choose. Okay, so now let's move on. So how do we separate a mixture? We'll basically use a magnet to separate the mixture. So please fill in the blank there. And can you tell me what do you think this will leave behind? The first helping word is given to you. Yes, you are correct. It will leave behind the sulfur powder behind. Okay, so basically your sulfur powder, the physical property is it is a non-metallic substance. So therefore, since you have iron, okay, now the physical property of iron is that it is attracted, okay, it is attracted to magnets, whereas this is not attracted. And so since you have two different physical properties here, one is attracted to magnet and one is not, so you can safely choose your magnetic attraction because of the physical properties of iron as well as sulfur. Okay, so you can see how the factor of physical property basically affects the type of method that you want to choose. Okay, so let's move on. Now, what does your magnetic attraction allow? Basically, it has allowed for, it has allowed for a quicker and more efficient separation of magnetic materials from non-magnetic in many industries. So currently, you see, so now we talk about the definition. Okay, we spoke about the definition of magnetic attraction. We say how physical properties have affected the choice of magnetic attraction. We talk about an example of how magnetic attraction is being used when we want to separate iron from sulfur. We talk about the advantages of magnetic attraction, which is it being quicker and efficient. Now we're going to ask ourselves, where is magnetic attraction actually being used in society? So what is the relevance? Why do we even bother learning about magnetic attraction? Okay, now magnetic attraction is actually used in many different types of industries in society. So the relevance is predominantly in, number one, the salvaging of iron and steel. Now the word salvaging means, okay, the word salvaging means that you actually want to save, or you basically want to recycle or reuse your iron and your steel. So in certain industries, they want to take away the iron and the steel from, I don't know, maybe let's say left behind motor vehicles. They may use magnetic attraction to separate iron and steel from the rest of the other substances, thus allowing them to recycle or reuse the iron and steel for making, okay, for making new items. Okay, this is quite important use, so you may want to put a star here. Next thing, they also use it in food processing. Now you might ask, Miss Lee, what exactly is this? So let's move on to the next part to find out what are each of the industrial applications of magnetic attraction. Okay, so over here you can see the two examples of how magnetic attraction is actually being used in industry, or in basically in society, the relevant applications of it. Now, so you know what are junk yards? Basically, junk yards are like areas where they dump, okay, rubbish. Okay, now in your rubbish, you may have scrap metal, okay, and some of this metal you want to reuse and you want to recycle. All right, so what do they do? You see, amidst all this pile of rubbish here, some of this rubbish could actually be paper, plastic bottles. Okay, there could be, I don't know, glass bottles, could be cardboard boxes. So they're basically a dump yard. Okay, however, inside here you also have metals that are useful, that can be recycled. So what do? They use a very powerful magnet here, and then they put the powerful magnet on top of this junk yard, and then they will basically attract the iron and the steel. So because of the physical property of iron and steel, okay, so because iron and steel are magnetic, all right, so these are magnetic substances, that means they are attracted, okay, they will be pulled upwards. All right, and then the magnet will basically be brought to this green, what is this green container truck, and what they will do is that they will switch off the magnet, then the iron and the steel will basically drop downwards, and so then this will be a collection of iron and steel. So the metal will then be sent to your recycling centers, and then they can be used to make, let's say, taps, pipes. Okay, they can be used to make metal bolts, okay, in new objects. So that is why we use the word salvaging, because the word salvage means to save something, and in this case we are trying to save the iron and the steel because we want to make sure that we can recycle it. Okay, now let's move on to the next one, which is food processing. How do we use magnets in food processing? Here you say, Miss Lee, you mean our food actually contains metal? Not quite. So let's have a look at this. This is a field of corn and grain, and sometimes when they use all these trucks or these tractors to help in the harvesting. Now the word harvest means they go and collect all the crops from the field. So when they harvest the crops using these machinery, sometimes small metal pieces can actually fall into the grains here. Can you imagine eating your favorite Nestle cereal, and then after you put the chocolate, the Cocoa Pop in your mouth, and then you chew and say, hey, how come got one iron piece here? I think it'll be quite dangerous, right? So what they do is that in the food processing, they will basically put these collected grain particles in this big, huge magnetic separator. Now in this magnetic separator, there's basically a giant magnet here, and what they will do is that they will help to attract all the metal pieces from the crop. So inside here, imagine all these blue dots that Miss Lee is drawing, okay, are your magnets. Okay, are your magnets. So when they put in all the seeds or the grain inside this container here that contains magnets, okay, what they will do is that these magnets will then basically attract all the metal pieces that have accidentally dropped into your crop. Then once the grains or the seeds come out from this machine, they are basically clean, or they are considered pure, because all the metal pieces have been removed, separated. Okay, so that is why when you eat your cereal, we can say that your cereal is clean, okay, and it is safe to be eaten. So can you please take your highlighter, okay, highlight the word separator, metal pieces, okay, so removal will make the food clean and safe to eat. All right, so this is something that you will need to know. This is quite a useful application of magnetic attraction in the salvaging, okay, of iron and steel, as well as in food processing. So remember, in iron and steel, we want to make sure that iron and steel can be recycled. Why? Because they are limited natural resources, so it is useful. In food processing, when we separate it, we do not want to separate the metal so that we can eat the metal. No, but rather in food processing, magnets are used to remove harmful objects. Okay, so remember just now the two benefits of separating mixtures is so that we can get useful substances, right? So over here, you can see that we are trying to get the useful iron and steel. Over here, we are trying to remove all the metal pieces that have accidentally dropped into your harvesting of the grain because of all the machineries here. All right, so now you can take a moment to pause the video if you need to, so as to digest whatever materials that we have just discussed. You may pause the video here to take some time to read your notes. All right, so let's move on. Now I would like to draw your attention to the concept map on page 20. So what have we learned in so far? Okay, now this is your concept map. We have learned that separation techniques can be used to separate. Yes, you're right. It can be used to separate metal. Very good. And then based on the physical property, we talked about magnetic attraction, right? So we say that if we want to separate magnetic and non-magnetic materials based on their physical properties, we will basically choose magnetic attraction. Okay? And in magnetic attraction, we will use magnets. And can you tell me what we are separating? Okay? We are separating the magnetic materials from non-magnetic materials. You're absolutely right. Okay, so I'll show you again. We are separating magnetic materials from non-magnetic materials. Okay, and what are the industrial applications? We say that it can be used for salvaging iron and steel, to get the iron and steel from inside your junkyards because you want to recycle them. And they can also be used in food processing because you want to make sure that your food is safe and clean to eat. So you want to remove all the metal pieces that may have dropped from the inside of all the machine when you are processing the food. Okay, so now we have come to the end of magnetic attraction. We are going to introduce ourselves to the next type of separation technique. And the next separation technique is known as filtration. Okay, now you would have learned what is filtration. All right, now filtration basically comes from the word filter. All right, it comes from the word filter, and it is basically separating an insoluble solid from the liquid in a solid liquid mixture. So there are a lot of big words here, right? So we say that filtration, all right, you may want to highlight this. Okay, filtration is a separation of an insoluble solid from a liquid. Now, why can we use filtration? Because an insoluble solid, right, cannot dissolve, so it's not known as a solute. Okay, it cannot, all right, it cannot dissolve in this liquid. So if you were to draw a beaker, and if this is a liquid, an insoluble solid will basically be formed at the bottom here. So if I say that I want to obtain this solid from this liquid, all right, so this is your insoluble Okay, this is your insoluble solid, and this is your liquid. If I say that I want to obtain the solid from the liquid, I can use the process of filtration. So if you look at the word filtration, what does it sound like? It is an apparatus that we used before in the lab that looks something like this. Yes, some of you have guessed it correctly. It's a filter funnel, but you will also need to have a filter paper. Very good. Now, if you have a filter funnel without a filter paper, this technique is completely useless because all the insoluble solid can actually pass through, right? But what we need to have is we need to have a filter paper here so that the insoluble solid will be trapped in the filter paper, but whatever that seeps through will be your liquid. Okay, so can you guess what is this solid liquid mixture that we are talking about? Is it a solution or is it a suspension? Maybe you want to take a moment and think about it. And at the same time, let's look at the question. Is orange juice a suspension? Yes or no? You may want to pause the video here, okay, to attempt the question. All right, so let's come back to this. Now, I just asked you to think about whether it is a suspension or not. Okay, so an insoluble solid in a liquid. Now, if you look very carefully here, you can see that all the solid particles are sort of like suspended in the liquid and then they settle down, right? So actually what we're talking about is a suspension. So we use filtration when we want to separate suspensions, okay? And orange juice is a suspension, just like your apple juice and your calamine lotion. And that's why whenever you look at the back of these bottles, they will always ask you to shake the mixture before use. Now, if you don't shake, all your apple will be at the bottom, all the solid particles in your calamine solution will be at the bottom, suspension will be at the bottom, and all your pulp, the flesh of the orange juice will be at the bottom. So orange juice is considered a suspension. That's because the pulp or the flesh, the apple over here, or the powder inside calamine lotion, they are all, what do we use the word? They are all insoluble solid. Okay? All right, so let's move on. Yeah, so you may want to take note of this. Take your highlighter, okay, and highlight insoluble solids suspended, okay? And yes, we already said that orange juice is a suspension. So let's move on. Let's go on to page 5. So filtration can be used to separate insoluble solids from suspensions. What do you need to have? You will need to have a filter. Okay, you need to have a filter funnel and a filter paper. All right, now, so filtration works on the basis that, that means what is the principle of filtration? Why is filtration so such a useful technique? Basically, filtration works on the basis that number one, in the suspension, there are insoluble solids that are larger than the liquid particles. Now, because these insoluble solids are larger than the liquid particles, okay, it will basically help them to be separated from the liquid. So if you look at this example over here, if you look at this over here, you can see, all right, Miss Lee will point to you. You can see that these are the larger particles, right? Now, what are these particles known as? These are your insoluble solids. Now, these small little blue dots are basically your smaller liquid particles. Okay, now if you look carefully here, you can see that this is your filter funnel. You can see that this is a magnified, that means I went to enlarge this diagram for you. This is actually your filter paper. Okay, so your filter paper is here. So you notice that your filter paper has got tiny little spaces here. Now these spaces are known as pores. All right, now you will notice that your large insoluble particles, which are larger in size, they cannot pass through this pores, right? So what will happen? They will be trapped inside here. But you notice that your liquid particles here are small enough to pass through, right? So when you pour this suspension through the filter paper, the larger particles will be left behind in the filter paper, but all these liquid that is passing through is because your liquid particles are small enough to pass through the holes. So actually, your filter paper has got many pores or small holes. Now, these small holes will allow liquid to pass through, but not your insoluble solid, because your insoluble solid is larger in size. All right, so this is a physical property, right? Because the size of the particles are basically preventing it from passing through the filter paper. So now these particles, this insoluble solid that is left behind, we will call them your residue. So can you see all this brown substance here? Now this is your residue. What about the liquid that can successfully pass through the filter paper and be collected inside this apparatus? Can you tell me what is this apparatus known as? Good, you guessed it right. This is a beaker. Okay, so the liquid that's able to pass through the filter paper, okay, goes through the filter funnel into the beaker. We call this liquid the filtrate. Okay, so that means in the process of filtration, whenever you filter a suspension, you will always get two things. You will get the residue, which is the insoluble solid, and this is the one that is left behind in the filter paper because it's too large to pass through. And the second thing that you will get is the filtrate. Now, the filtrate can be collected in a beaker. Why do we get the filtrate? Because these are small enough particles to pass through the membrane. Okay, so there are small particles that can be passed through the membrane. So far, all right? Okay, so now let's take some time to fill in your notes because I think you should be able to understand the process better. All right? So a suspension is passed through a filter paper. So you can see you pass through the filter paper over here, this whitish conical flask looking thing here, this conical shape here. This is a filter paper. Now you see that what I have done is I've magnified, okay, I've enlarged the filter paper. So this is microscopic. You can only see this if you use a very high powered microscope. These rectangular boxes here resemble the filter paper, the cross section of the filter paper. You will notice that there are some gaps, these holes in the filter paper. Okay, now the filter paper has got tiny pores. So you can see that these pores here, okay, now you will notice that you can see these tiny pores here. Now these are the tiny pores. All right, and these tiny pores will allow all your small particles over here. You can see small particles of liquid to pass through, okay, but they don't allow these larger brown insoluble solid particles that are larger in size to pass through. All right, so the large insoluble particles are trapped, okay, and then once they are trapped, they are known as the residue. So the trapped particles that, sorry, this word shouldn't be residue. Can you please make a change in your notes? It shouldn't be residue. We should use the word remain. All right, that remain on the filter paper is known as the residue. Okay, it's known as the residue. Sorry, let me erase this again. Don't think you can see it. All right, it is known as your residue. So let me write this for you again here. So please spell the word correctly, yeah? Is known as the residue. Okay, so the liquid that, can you guess what this word is? The liquid is actually, what is it doing? The small particles are small enough to do what? Go through this. So what do we use? You are right. We say they are small enough to pass through the filter paper. What do we call it? There is a liquid. We call it the filtrate. Now, why do we use the word filtrate? Because look at the process. It's known as filtration. So in filtration, we will always use apparatus or materials that got this feel. So we say filter paper, okay, filter funnel. Then now we say that the liquid that can pass through is known as the filtrate. So you notice in filtration, you are basically separating an insoluble solid from a liquid. So you will get the liquid here and you will get the solid that is left behind in the filter paper, otherwise known as your residue. Okay, so please make sure that you check your notes and you fill in your notes, you can actually take a moment to pause the video here so that you can successfully fill in your notes. Okay, let's move on. So welcome back if you have paused the video. Just like how your magnetic attraction basically has got relevant industrial applications, there are also relevant industrial applications of filtration. So one of them basically includes coffee makers. Now, if you look at the coffee maker, if you look at your coffee maker here, you can see there is a filter paper here, and then you have your coffee powder, right? So what you're going to do is you're going to put your coffee powder here, and then you're going to fill the hot water. So you're going to go pour the hot water into the filter cone. This filter cone is also known as your filter funnel. Notice that everything has got the word filter because we're talking about filtration. Okay, so basically what will happen is that when you pour the water here, the water will seep through, okay, all your ground coffee here, and whatever filtrate that comes out here will basically be your liquid coffee. All right, it will be your liquid coffee. So this is an example of an industrial application. Basically, it's your filtration, known as filtration is actually also seen inside your coffee maker. All right, next thing will be water treatment plants. Now, this is very important in the next part under 4.3 when we talk about Singapore's production of tap water from reservoir water, from imported water, and even from sewage water. Water treatment is very important. Now, the word water treatment means that you must make sure that the water that comes out from your tap is actually clean and very safe to drink. So, filtration is a very important process in treating water to make sure that the water that comes out from the Singapore taps are clean. And actually, not only do we see this in industries, even your body, the amazing human body. Okay, for example, your kidneys. All right, now your kidney in your body and your nose hair also allows for filtration to take place. Quite amazing, isn't it? So basically, your human body also makes use of this process of filtration. So let's look at your coffee maker. So what happened is that you can see that this is your filter paper, the one that Miss Lee is shading. Now, what you see is a cross section, okay? So it's a cross section of your coffee maker. Now, what happens? You will pour water, and water will basically seep through all this ground coffee. Now, after a while, the filter paper, this is your filter paper. You can see this white substance, right? So the filter paper is here. Water is able to pass through the filter paper because water particles are small enough. But your ground coffee, okay, your ground coffee particles are very large, so they cannot pass through. So what will happen is that your filtrate that you will come out from the filter paper here will be known as your liquid coffee. And in your liquid coffee, you shouldn't see any more coffee particles because whatever coffee particles have already been left behind here. And can you guess what is the left behind, the ones that remain? What is it called? Good. It is known as a residue. What is your liquid coffee called? If you guessed it correctly, it is your filtrate. Wonderful. All right, so let's move on. Okay, so as mentioned just now, wastewater treatment or the usage of filtration in water treatment is actually very important. Now, the water from our reservoirs must first be purified. Now, the meaning of the word purified means it must be pure, it must be clean, and therefore the process that we use is actually filtration. Now, why is filtration used? Because it is a very cost-saving technique. Okay, that means it is very cost-effective and it's cheap. So what happened is that the raw water from the reservoir will be treated with chemicals first to kill all the germs and your bacteria. So these chemicals will be used to get rid of germs and bacteria. And then what will happen is that your raw water, if you look at this picture over here at the side, this is your raw water after it has been treated with chemicals. Okay, your water will then pass through many different layers. Okay, so first it will pass through the first layer known as fine sand. Now, sand is insoluble solid. Okay, then it will pass through your gravel, which is also insoluble. Then it will pass through a layer of pebbles. Can you guess why it has to go from one layer to one layer? What are you trying to do? Now, remember, your water particles are small particles. They can pass through your fine sand because in sand, there are still some spaces in between the sand particles. But your water particles are small enough to pass through these spaces. So what are you trying to do? Can you guess? Yes, you are trying to filter, okay, the raw water that has been treated with chemicals. You are trying to get rid of any other particles other than germs and bacteria that could be still present in the raw water. Okay, so water will then be filtered through your different layers of sand and grains of different sizes. So why do you want to use grains of different sizes? Because you're trying to trap particles of different sizes. So probably in your um, all these three layers, fine sand, gravel, and pebbles, you're basically trying to make sure that whatever water that passes through this, okay, whatever water that passes through all the way to the bottom here, eventually you will get clean water. Okay, so when it goes from the first layer to the second layer to the third layer, basically you are filtering your raw water because you want to get clean water. Okay, you want to make sure that the water that you have inside your glass is clean so that you can drink it and that it is safe. All right. Okay, so your solid silt. Silt is basically like it's not really like sand, but it's a smaller version of sand particles. Okay, so your solid silt and your sand particles will be removed from the water. And that's why you want to use layers of different sizes. You want to use pebbles of different sizes so that you can get rid of different particles of different sizes as well. Okay, so then the clean water will then flow out, and of course this clean water will then be further treated to make sure that whatever that you get out of your tap water is really clean water. Okay, last but not least, there are certain parts of our bodies. We talk about your kidneys and your nose hair, okay, that can be used to filter. So our body can also use filtration to control the type of substances that enter and leave our bodies. So in the example of your nose hair, basically when you breathe in your air, okay, there are actually some microscopic dust particles that you can't see with your naked eye. But what will happen is that your nose hair basically acts like they basically act like uh, so when you see these are your nose hairs, right? So basically when air actually enters your nose, what will happen is that your nose hair will basically trap all these dust particles. So when air goes in, the first layer of defense is your nose hair. It's like a curtain, you use a curtain because you want to cover your window to protect yourself from strangers peering in or from too much sun, right? So your nose hair is basically there when air actually enters, it wants to get rid of the dust and the foreign particles. Okay, the next thing that we that also uses filtration is basically your kidneys. Now your kidneys are so important because they help to filter the blood from waste substances. Now these waste substances are toxic. They cannot accumulate. Okay, they cannot become more and more inside your body. So your body needs to get rid of it. So it needs to remove these toxic substances from the blood. So your kidney is very important. That's why you notice when they suffer from kidney failure, they have to undergo a process known as dialysis, right? And in dialysis, in Chinese, we say 洗血. 洗血 in Chinese means to literally wash the blood. Now, why are they washing the blood? Actually, they're not washing it like a washing machine. They are basically filtering the blood. So they are getting rid of all these toxic waste substances from the blood, such as urea and excess salt. So whatever blood that returns, okay, so this is the blood that needs to be filtered. Whatever blood that returns back to the body, so over here is back to the body, all right, will be blood that has already been cleaned and therefore filtered. Okay, that's why your kidneys are so important. Now, if you look at this animation, you can see what is happening. Don't you think this actually don't care about the words here, right? They are not something that you will need to know at your level. You will learn them in biology in Sec 3 and Sec 4. So you will notice if you look at this, you can see that there are some movement of substances, right? So you can see that this actually looks like your filter funnel, looks like a shape of your filter funnel. You can see that this tube-like structure here looks a little bit like your filter paper. And what do these three arrows represent? These three arrows that are coming out here, okay, here, here, and here, they represent the movement of these substances. So these waste substances that are coming out from the blood to be filtered out into your urine. So this is actually found inside your kidney, okay? All right, so we have just finished the last part, the second part of your separation technique. We talk about the second type of separation technique, which is to separate liquid and insoluble liquid, basically using filtration. So what do we want to get? We want to make sure that we want to obtain an insoluble solid. Very good. You want to obtain an insoluble solid from a suspension. So if you want to get the insoluble solid, then you will use a suspension. From a suspension, then you will use filtration. And the two examples will be found in your coffee makers and your water treatment plant. Okay, this brings me to the end of our first lesson. We will continue our second lesson tomorrow. You may take the time now to read through your notes and prepare for the next HBL lesson subject. Thank you, and we will continue tomorrow.